Hello, everybody. My name is Philip Butterworth-Hayes. I'm the editor of Unmanned Airspace, and I would very much like to welcome you to this latest ANRA Huddle, where today we're going to be talking about the integration of air traffic management with UAS traffic management, a really interesting and important topic at this time. This is going to be recorded, this session, so you'll be able to have an opportunity to go back and listen to the highlights, of which I'm sure there will be many, because we have a really fantastic lineup of speakers here. Steve Bradford, the Chief Scientist for Architecture and Next Gen Development of the FAA, focused on UAS automation and international collaboration. Andrew Haitley from Eurocontrol, a Senior Researcher in U-Space and Urban Air Mobility. Thomas Lutz from Frequentis, the Principal System Architecture for Drones. We have Genghis Ari from the CISAR Joint Undertaking, the U-Space Program Manager. And of course, Amit Ganju from ANRA, founder and CEO. So thank you very much indeed. This is going to be, I think, a really significant event. So we will be taking questions 15 minutes from the end, and I would encourage you to put some questions forward if anything's unclear or we haven't covered anything. So very, very briefly, if I'll just sort of recap on where I think we are and what we should be talking about. Integrating UTM and ATM is not easy. We're talking about two completely different systems. One legacy system with the humans still very active doing voice communications in the process of digitization, but only at the start of that. UTM very different, very new, automated, using digital technologies. And merging these together must be not just a technical issue, but quite an institutional problem too, especially when you look at a UTM not merely as a centralized, but perhaps also as a decentralized architecture. So both of those will pose integration issues. What I'd love to get out from today is just a few things. Where are we on this journey, this roadmap of integration? What are the key challenges that's left? What kind of time scale are we talking about where we can start to see the first truly integrated UTM, ATM architectures? And a few basic things like what kind of data sets need to be integrated? What are the minimum sorts of data that needs to be integrated so they can work together as a harmonized whole? And how's that going to be done? What kind of standards are we going to use? So that's kind of like the big picture. Steve, perhaps I can talk to you first, asking where are we on the journey? So if we look at the ultimately digitized ATM system with UTM and high airspace operations entirely integrated into the single platform, where are we on that journey?
Well, I think we're doing pretty good in what we consider in the United States the UTM environment, which is 400 feet below, especially away from Class B at this point. And we have a demonstration in Texas where we really are demonstrating that the community can, the small community can actually take care of itself with our guidance and approval of their rules. Where we still have questions are, in beyond visual line of sight in Class B. For our commercial visual line of sight, they still below the maps, everything. We treat them just like they're in Class G. Where it gets more interesting, of course, and I think that's going to work pretty well. And that is a lot of, I'm going to say, strategic information sharing. Our controllers never really want to see these vehicles at all, so they can be segregated from the controller perspective. Where it gets more interesting is when you move up about 500 feet, and now life there is either you're flying in ATC or it's going to be some sort of sterile airspace at the beginning. And for the most part, we think they're all going to fly in ATC. And at the highest altitude, then you get back again to where you are probably at the lowest altitudes, except for they have to transition. Nobody starts at the highest altitudes. We have to figure the transition through the air traffic system. I think the most challenging will be in the Class B, Class C environment. When people want to fly at 1,000 feet, 2,000 feet, 3,000 feet, and at large scale, and we're not that far yet. We're saying you're going to fly an ATC for now, and we're still working on the concepts there.
So in terms of the time scale, I know I don't want to push you too far, but how far have we got to go, do you think? I mean, 2030, would you expect to see that sort of time scale for when
I
will
would
that be?
say, I would say the first time we really have, well, now the autonomous, the remotely piloted ones are going to be the more interesting ones. I think that if they scale up probably 2030, 2031, 2032, we're going to have to figure out how to allow for a higher volume of these 1,000 to 10,000 foot aircraft in Class B, where they can't swamp what the terminal controller can handle. And so I think that that's probably more likely 31 or 32 if if it scales the way the community would like it to scale, the business community would like it to scale. The remotely piloted ones, I think, will be in the same camp, except we have to figure out how to totally integrate them into ATC, which means we have to figure out how they can communicate directly with the controllers and be in the party line. And for me, that's a big issue.
Right, thank you. And that's really interesting. A whole lot of stuff comes out of that. And Andrew, I'm going to throw a few at you. What do we mean by integration? Is integration just having a tablet in the control tower where the controllers can see where the drones are, or is it fully integrated into the flight data processing system and the radar screen? What does integration really mean in this area?
Well, I mean, there are a number of problems that we're trying to solve here. The driver in the European perspective are these passenger carrying operations, so these eVTOL or VCA, which we're calling them. And they have been told in Europe that initially they can operate as VFR, but as soon as possible, they're going to want to operate as IFR because they want to offer a service in all weathers. And as soon as they're able to operate IFR, they will be pushing to be remotely piloted because today we can operate RPAS IFR. So when we get to that, the first pressure which emerges is the pressure of a large increase in traffic. Today, these regions that Steve was talking about, they're near airports, but the tower control and the approach control are not looking for an extra few hundred aircraft to control. They're not ready for this. They're not geared up for this. So there's a manpower effort, and that's where we would start to see an advantage if ATC could take over some of the methods and processes which we're using in UTM today. And the big one is not really that we would take over the kind of the separation process or anything like that. The big one is today ATC is fundamentally a service delivered by a human being. The controller is on the radio and he's speaking to the pilot. He has tools, but they make the controller more effective. We need to switch over to a point where the service is being delivered by a piece of software where that's possible, and the human is there to do the more interesting parts of the job, the parts which cannot be easily automated. So that's one level of integration. That's probably the most contentious level, but that's the area where we will get the most benefit. But integration comes further if we can try to avoid segregating, as we do today, the small UAS from the rest of the aviation. Today in Europe we have this construction called U-Space Airspace, which is an arrangement where we can do UTM, but we keep the manned aircraft out as much as possible. And this segregation is wasteful of capacity. We end up having to divide up the sky between one class of user or another. And we would approach the problem of integration as being an integrated airspace as well. We would like to be able to have the small UAS flying without restricting the flight of the manned aircraft, and likewise there will be applications for small UAS which will want to go higher than we're currently considering. So we will have to find ways to integrate the airspace. And there we come to quite a number of technical challenges that we need to follow. Like today, manned aviation, our kind of unit of measure is the nautical mile. For the small UAS, it's meters. So this idea that you talked about adapting the flight data processing system of a current ATC center to be able to handle UTM type traffic, it would be expensive. So we need to balance, where the benefits are in the short and the medium term and the longer term to decide how we're going to do this. And the short term need is being driven by these passenger carrying operations. They would like to fly above 500 feet. They would like to fly remotely piloted, which will force them in the short term at least to IFR, because we know how to do that for remotely piloted. So we need to find a way to increase the capacity of ATC while taking on some of the work of UTM.
Great, thank you. And helping find that way is one of the jobs of CESAR. So I'm going to turn to Genghis now. I'm looking at this outside. This is a complete nightmare. You've got the evolution of three systems. You have the digitization of the legacy air traffic management system. You have the introduction of U-Space for drones. And at the same time, you've got this rolling wave that Andrew talked about of passenger eVTOL. So somehow the research has got to come up with a holistic kind of solution to all these different evolutions, some of which you haven't even started yet. So from a research point of view, how do you integrate all this into a way that actually makes sense when you come to deployment?
It may be complex, but on the other hand, I see that maybe, okay, let's start with a blank sheet and let's try to make it more efficient possible, taking into account the legacy, as you said. Just for this problem about integration ATM, UTM, for instance, as an example, to the contrary of all the projects that are dealing only with the U-Space, UTM, and just their digitalization part, we asked for a specific project to consider this problem, the ATM, UTM integration, from ATM perspective. Then we asked the industry, guys, you have to talk with the drones, you have to talk, and you have to manage drones in your control area. How do you do that? What are the technology you would use? What are the needs? Then what are the needs of the ATCO? Then in fact, finally, even we end up with a project that is progressing well, a second project then called Ensure, that is targeting Terral 7, with a good approach, a positive approach, an open mind approach from the ATM community to digitalize their own activities and onboard the UTM world in their control area. Specifically, this notion of dynamic airspace reconfiguration is worked in place, tested now, and this is proving to be good. In terms of infrastructure, they themselves, they came with a proposal of using ATM well-known technologies or like the stream layers type of exchange of information that has been proven to be robust in the ATM world, and now that is also used with some adaptation, some improvement that maybe Tom can explain later on by the UTM world.
So there's an interesting thing you said there. When you said TLR 7, that's technology readiness level 7.
Yes, exactly.
So that's almost ready for implementation. That's pretty close to actually being ready for operations.
You're right. In fact, this technology, this approach, these notions are being used also by other projects that are even moving further to Terral 8 in Belgium and in Spain, where this notion, this type of exchange interface will be implemented. Yes, I think that some solutions are mature. As you said, maybe some screens on the ATCO side minimize the impact, but still some awareness for the ATCO. But for the moment, this is well in place and probably in operation in some context early 2025.
Oh, fantastic. Thank you, guys. Thomas, I'd like to turn to you now, please. So if we look at the two things that are happening here, where we have UTM principles, digitization, automation, slowly starting to creep into the traditional air traffic management world, and we have the traditional air traffic management world having to adapt to these digitization technologies, including things like trajectory-based operations and data link and stuff like this. In terms of the technology, in terms of the transfer of technology between these two worlds, what's the is it just software? Can we simply just write code and software and integrate it relatively easily, or is there a lot more complexity in the processes and the cyber side? I mean, what's the technical issue about integration?
It could be super short answer. That there's never technical issues. We just need a specification to implement. So I think that specification or the plan, the approach is the one thing that we need to figure out. And is a tablet in a tower the way to go, or is it to find a solution, adopt? But the way how we get there is we ask people that currently deal with the situation, that currently manage traffic, on what they need. And we ask drone operators what they need. And best we do that in one room. And this is what Cesar and the projects enable us to do. We come together and we try to create a common understanding of what we do. Find words that we all understand. Find a few on the world, on our world, on aviation, that we all understand. And by using the same words and by having the same view, and then documenting that in drawings, in prosa, so that everybody can understand, we can decouple technology from concepts. And we went from legacy to traditional systems that we have to integrate with. And I prefer actually proven systems. Just because they're old, it doesn't necessarily mean they're like bad or should be immediately be replaced. There's a lot to learn there. The concepts, they are quite stable. And if we find a way to describe that concept so that everybody understands using the same word, the technology part and the implementation will follow. And then once we've reached that stage, it's going to be a bit of software, probably a lot, some hardware, but still a lot of understanding on all sides, on all participants in that one integrated sky that we're looking forward to see in a few years from now.
But as somebody who's involved in developing the software, well, this is very radical. So you're not just in the future going to be a software provider or integrator. You're going to have a bigger role. Industry is going to play a much bigger role in the future. So they're going to be doing, providing services that at the moment are provided by hardware. So you can imagine somebody coming along saying, okay, in this integrated UTM, ATM world, we will need people to provide the kind of things that ANSPs are doing at the moment. So what's Frequentis going to be doing in an integrated UTM, ATM world? Not just writing the code, but actually, are you going to be providing any advisory services, any surveillance, perhaps communications? Is this a change for you?
It's a huge change for us. What we will provide we had the number before 2030. Let's have another huddle in 2028. Then I can really say where we are going there. It will change for sure. If it's the role of working on the technology side, specializing in supervising the services that run, in a meaning of making sure that they don't, that they do behave in a technical way. Or if it's more, there's still a few steps to take until we're really there.
Yeah, I'm sure. I mean, you've been looking at this globally now. You've seen where everybody is. You see where Europe is. You looked at the you're involved in all continents. Everybody's taking a slightly different approach. What's your view as to where we are globally in terms of moving these two environments together? Where are we? Who's winning? I hate to say who's winning because we're all winning, but what approach do you think will offer the best solutions in terms of scale, price, safety, security?
No, I think that's a great question. And I think I always say it takes a village. It's not one person can't solve this problem. And I don't think there are pros and cons to all the approaches. And the speakers talked about the different challenges. I think we're talking about bridging ATM and UTM. But what I always say is I always talk about three phases: innovation, experimentation, operationalization. In this case, I'll say crawl, walk, run, because we, like some of the concepts we are working, some of the deployments that are happening, whether that's with USpace in Europe or Keysight in US, you are seeing early operationalization happening. But to the event, if you fast forward 15 years from now, the air traffic management, the way we see it, will it exist in its current form? Probably not. It'll be a more form. But are we going to get there tomorrow? We are not going to get there. So we need to have these incremental steps in the middle, which is why bridging the gap between ATM and UTM is very important. So some other challenge is, we know that systems have to integrate and talk, but we don't have to what Andrew talked about and Steve talked about. The traditional the controllers don't want to see all this traffic all the time, because you're going to go from 10,000 crewed aircraft in the sky to maybe hundreds of thousands, millions of drones in the sky at the same time. You don't want all of them on the same scope, same dashboard. So what's important is what information needs to be shared and when does it need to be shared. It's not how we share. We can figure out, like Tom said, we can write software and move ones and zeros all day long. It's when do you share it and what do you share? Once we agree on that, then it's just formats and translation of the systems. So there's a lot of good work happening in Europe with CESAR research projects and USpace deployment, with certification happening, and with the Keysight initiative. I think what's hurting us as an industry is bread bowl discussions right now, because there are different business models at play. That's biasing people's view as they look to come to a solution that can scale internationally. For us as a technology provider, and I'm sure Tom will say the same thing, we don't want to build solutions that only work in, because I think those days of building black box solutions are gone. You can't build a business based on black box solutions. You need to have solutions that deploy around the globe. Because imagine if Boeing or Airbus were building aircraft that only worked in one country, we would have a problem, right? Similarly, we need a system that can be deployed in US, Europe, and elsewhere. So I think we'll get there in a gradual path. And we just need to, at this point, define what are those data exchanges? Can we use existing mechanisms for those data exchanges? Do we need translators between the two worlds? And what Steve talked about, like in some cases, we have to move away from your traditional voice comms that you used to use, especially when you go to these remotely piloted eVTOL aircraft. So how do you translate that to the digital world? Because that's what we need. And there's a lot of work that has happened in US and Europe in projects, which is moving the needle.
So thanks, Amit. Let's just pare it back a bit. Andrew, what do you think the controller will want to see? He won't want to see, or she won't want to see, thousands of drones flying around. He or she will just want to see something that might affect their
it's worse than that, actually. The controller doesn't want to see things they're not responsible for. In fact, it's been said to me, if I see it, I will become responsible for it. So just show me the things which I'm actually paid to work on. So yeah, the controller is limited in their ability by the ability of the human brain to process the parallel information that they're bombarded with. So it is really desirable not to clutter their view with irrelevant stuff. And so we can improve the situation with software by helping determine what is relevant. But the problem is slightly more than that. I mean, we're talking about integration of ATM and UTM in this discussion, but we have to recognize that ATM has always been rather, well, in my lifetime, has been rather slow to change to new technology. And this is driven by the fact that there is a working system. Necessity is the mother of invention, and we have a pretty good system today. So there's not been a strong impetus to change. But the result is that we're still living with things which are rather archaic. And when we've come along and we've developed our UTM world, the first premise of what we're talking about is everybody involved is connected and online, and we have rapid data exchange. And the premise of current air traffic control is that the pilot will look at a notice board before they walk out to the aircraft. And this is, it's just not sustainable in the same level of performance. So we have an opportunity here to integrate ATM and UTM in order to bring ATM up to the kind of the modern era, and showing the controller what they need to know in a timely manner is perhaps less of an issue than showing the other participants in aviation what they need to know in a timely manner, the pilot particularly. And that's quite a big nettle to grasp.
Yeah, and I think this is where I think we're in, where the real challenge is. Because Steve, I don't know whether you'll agree with me on this. The ATM system that we have now is based on software which was really obsolete 10, 15 years ago, and just the sheer amount of work required to keep that working means that we can't introduce the capacity we need to do all the things we need with future technology. So the longer we delay, the more radical the leap will be into digitization and joining UTM and ATM. And in terms of not just the technology, but culturally, do you think controllers in the USA are ready for this quite radical change, the biggest change they'll ever see in their lives, as they move towards digital, as they move towards UTM, as they move towards some of the things we've been talking about?
I think we forget that the slowest part of aviation today are the aircraft and the pilots. That aircraft actually last longer than our automation systems and our software. I mean, we got, planes last 30, 40 years, and air traffic has to accommodate 30 or 40 years. And you have to, nobody's going to be able to mandate that all aircraft change. Now, I do think there are opportunities that the new entrants are providing, because they really can't use our navigation other than GNSS, and so we're going to have to find an alternative for when GNSS is spoofed or something else. And they don't fly where the DMEs and the VORs actually help them. So there's going to be new technology there. This is where I'm going to speak heresy. Is I don't think that 15, 20 years from now, I really care about ATM B2 or fans, because I think that, sending English messages to a translator on board an aircraft seems to me to be really old school. Once you start doing that, then I think you can break down some things, and you can really begin to, when the ground plays a bigger role with the management of the aircraft, then I think we can actually see movement forward. But voice is going to last for a long, long time. As long as when we say integrate, we don't say some of them are going to be flying and taking care of themselves, and we're going to tell the controllers to ignore them, because the controllers can't ignore anything unless they're in a pattern. So we're going to be stuck with pattern flying of some sort for 20 years, so that controllers can ignore certain, and they do a good job today in the United States. If I have a VFR flight, they just ignore it. Oh, there's a bunch of aircraft down there, but I don't have to worry about them. If those aircraft are in the mix, then there's a problem. So it's more than just a tablet. It's digitization really involves getting the air and the ground on the operator side integrated, not on our side. And we have to figure out performance-based answers to comm, nav, and surveillance. Otherwise, there won't be opportunities, performance-based opportunities for even our legacy aircraft to say, hey, I can use that. And that's not going to be, 35 years of trying to get people to adopt it. So I'm a little less optimistic, because I I'm spending so much time trying to get datacom with 20 or 30-year-old aircraft moving along. So I don't think it'll be 2035 or even 2038, but it could be 2045. But I think we can make a lot of inroads if we go to performance-based.
Right. Okay. Yeah. I mean, that throws up a whole set of other things. I'd like to go back, if I can, just to the original idea that I had for this, which is just looking at what data do we really need to transfer? Perhaps Genghis, you can help me with this one. When you look at the integration between the two systems, what's the minimum sets of data that need to go between UTM and ATM?
In fact, we did a reflection analysis about the type of data, and we realized that all the legacy traditional type of data used in ATM still needs to be used, no problem. Problem is that, the challenge is that we have those new entrants, multiple new stakeholders, many new stakeholders in the AM world, means that we have a lot of new type of data that needs to be handled. Some of them certified, half certified, not certified at all. And all those source of data needs to be handled. Those UTM are flying very low level, means that the type of data, if I take the example of ground risk analysis, if you have to make a ground risk analysis and submit your flight plan, for instance, it's not just the topology of the terrain that is sufficient. You need a map for noise, you need a map for privacy, visual pollution, environment, ecological impact, wind, micro weather, humidity. Then you need maybe layers of data that you have to combine. Those data are not necessarily coming from a certified source, maybe coming from public. For instance, if you have to make a flight plan, you have to know the density of population. You can receive that from LT, but you can also receive this information from municipality who knows that in 2 months' time, there will be a strike or there will be a concert in that area and you cannot fly on top of that. Then you have to integrate all those data, make a multi-layer map. Voilà, this is the challenge. And I think that the traditional legacy certified data, okay, we use them, but in fact, we need far more. And this is the challenge, in fact, that we have for the moment.
Okay, thank you. That's interesting. And I'd like to ask Thomas and Amit here, then what sort of kit do we need? What sort of technology do we need to handle all this data? What are you going to try and sell to UTM service providers and ANSPs? And what's the business model going to look like on this? I'm going to ask Thomas first, because you've had some experience with this, especially with when you talk to ANSPs. What will the technology requirements need look like for an ANSP that wants an integrated UTM ATM suite from you? What's your role in that?
Currently, we are the translator. So before I answer, I would like to play a bit or to talk a bit about the definitions. The title of the session is Interoperability. And interoperability basically means that systems or services and applications that are connected to each other speak the same language. And we very often mix up integration with interoperability. When I integrate with something, that means I make another system or component work for my own system, or the other way around. It always depends who leads. And I think we had that in the previous statements already. The challenge and the chance that we have here is to go beyond that and say what we actually want to achieve is speak the same language on things like, let's choose one example, a declaration of intent. There's many different names for that. A flight plan, in Chorus it's called a U plan, some call it operation plan. It's always the same thing. If you put up a list and say, this is what my flight will look like. I describe, I'm at that point in that time. I will fly with an aircraft that has a certain performance. Then the challenge is to translate this so that it can be received. Like Steve said, some aircraft will last for a very long time. So I can't just cut them off. I need to find a way how I translate that common language that we're about to find and define to that specific receiver. On the other hand, I might have super modern ground control stations, professional drone operators, digital natives, another word that we heard quite often. Will they use voice? Probably not. So I need to translate again to their level of technology, to their transport. It's likely going to use the same words in the language. We need to define them. We need to come up with a syntax, with semantics, ontology, all those great things. And then it's just about getting things connected. And now to answer the question, this is what we currently do: connect things without messing too much with those systems and things, because they're proven. They have partially a long history of operations. And on the other side, if you introduce the concept of sites, they seem to have a real need. So there's a reason why drones are operated the way they are operated. And what we do is translate between meters and knots, between feet and between, I don't know, topology of the ground and barometric pressure. That's all the things that we currently do. In future, I hope for integrated airspace, we will do much more. And the steps there, yeah, like I said before, we need a huddle every year to really figure out what's the next big one. But for now, most of it is translation. Amit, I took too much time. Sorry.
Well, I was going to say, I mean, just very, very quickly, whose job is that? Whose job is it to make the connections? Is it industry's job, or is it the regulator's job? Or, I mean, who's actually going to make those standards that we need to interconnect all this?
I don't think it's a regulator's job. Regulator's job is to define what the regulation is, what the end objective is. It's at the end of the day, the industry and the technology providers that figure out how are we going to exchange this data. As Tom very eloquently put it, we need to build, at the end of the day, all this means is we need translators, because we call these things different fields, but most of the cases we have the same data elements available. In some cases, there may be a superset or a subset where we have to add or remove, but then we need translators. So we minimize the impact to legacy systems, because the real world experience says the new entrants, it's very agile because it's all built from ground up as a digital technology. It's very easy for the new entrants to adapt. So we have to minimize the disruption to the legacy systems, make sure that translation happens. But more important is the system needs to have enough intelligence. When do I send it? Is it needed? And what to send, instead of overwhelming. Like, for example, if you were connecting with the ATM systems like Eurocontrol's network manager, what kind of flight plans would need to be submitted, right? For example, a couple of years back in UK, we did a project called Atomicus, where it was an airport to airport drone operation, right? So we actually submitted a UTM flight plan, which got translated to a flight plan that actually got submitted to Eurocontrol and got an approval and assignment, flight number ID assigned to it, and it flew in a digital world simulated. But those are kind of the things that are needed, and it's possible.
It's possible. Great. What are the steps?
I think it's important, I think Thomas brought it up, is that you don't we don't use the flight plan to control or separate. The flight plan is a plan, and then we turn it into intent with times, which, you know, on the ATC side they'll do it, in the UTM world they do it, and it really is all the same data underlying. It's just how do you want to structure it, and UTM doesn't need all the overhead of a flight plan, and the flight plan doesn't need all the specificity of a UTM intent. It's just it's the interoperability. You have to make sure that you can, if you're going to move from one regime to the other, at some parameter time before you move, you convert.
Yep, exactly. And this is so, Phil, and I sound like a broken record. I don't think it's a technical challenge. It's a business challenge, getting people to agree, because we can come up with common altitude references, so we can translate all these altitude, WJC84, MSL, AGL, whatever. It has been done, and CESAR projects have done it. Other NASA research projects have done it. It's just coalition of the willing we need to come up with.
And how's that going to happen? So how do you get the coalition of the willing to actually do that, to have standardized terminology?
As the government employee, I would say it's up to business to do this. We need to have a commercial incentive to do this. There need to be customers who want to fly among each other, and that will force the hand. I mean, as long as we don't need it, nobody will bother to implement it.
So a good example, I'm sorry, I'm jumping in here. So because Andrew said it, I had to say that. So the first example of that, well, one of the examples of, I shouldn't say the first, one of the examples of that is what's happening in Keysight, where we have 7 commercial operators that have a commercial business need to deliver products or do surveillance or whatever public safety operations in the same airspace. So there's a business need. If we don't solve that problem, that business goes away, it dies. So that's what's happening in essence. So the technology is being built with the governance, with the oversight from the regulator to actually enable it. And right now it's in one part of the country, and the hope is this model starts expanding. And I don't want to speak on behalf of the regulator here, but they are providing oversight and guidance here. And Steve, maybe you are a better person to talk to it. How do you see what's happening at Keysight maybe impact rulemaking and what happens beyond that?
Well, I think the Keysight will help inform whether we'd like to see the demonstration of the rule before we go forward with the NPRM, because the last thing you want is a standard that doesn't work or a rule that can't be met. So I think that's what it is. I think one of the key points here, and you asked the question, who's going to do it? I think really it's back down to the dollars and cents. Is, who's providing the service? In the United States, we can't provide the UTM service because of the way that the government funds its ATC system. So the industry had to figure it out themselves. Now, it's okay for them to do that because otherwise they would have been paying fees to us or something else. There's always a way of paying for it. The same model may not work someplace else, but the same information probably needs to be shared, whether it's a central provider or it's a federated provider. It really is. Exactly. It really has to be, industry has to agree to it because they have to build their side of it, or maybe they're building both sides of it like they are at the Keysight.
And that's really interesting, because if you look at a UTM system where the National Air Navigation Service Provider has the CIS, has the core infrastructure data, surely that'll be much easier for them to integrate into their existing air traffic management system than if you look at a federated system.
I really doubt that.
Okay, great.
If anything, you have to see as ATM systems kind of pop up, not integrated. And then Thomas will tell you spend a lot of time trying to integrate them afterwards. There is no master plan on the ANSP side, either. That's one would hope.
One would hope, indeed.
I think that's a wishful thinking myself.
I think we won't see the terms centralized and federated in like 5 years from now. At least that's my wish.
Oh,
because
really?
I don't think that the difference is
Why
that
not?
big. Yeah. Well, finding a definition for centralized would like blow up this huddle. We would need 2 hours. But it very much depends on the type of information. Some things need to be consistent. And on a conceptual level, this is something that we very easily will agree on. How we technologically afterwards solve that problem back at the beginning, that's like Ahmed's and my job to figure out and provide a solution that works. But I really like to get away from this, how to say, buzzwords, federated, centralized, because I don't think in real life there's that much of a difference.
Yeah.
Right.
Exactly. And Tom and us, we are working on some other projects off of this, nothing to do with this discussion, where we are trying to standardize some of these data exchanges. So it doesn't matter what model it is. It helps us move that information to the person or the system that needs the information at the right time.
Thank you. Perhaps I can ask Genghis here now. How much do you take into account of the business side of things when you're looking at CISAR projects, when you're up at TRL levels, number 7? As well as the technology, there's the other aspects, the economic side to it, and the role of the various stakeholders. How much of that is involved in your work?
By definition, each of the solution that is built by CISAR has two elements. One, the solution should be deployable. Then we are not doing just theory. The solution, what we do should be deployable. And secondly, it should bring benefits. Then the benefits can be euro or can be safety or can be improving the well-being of the passenger or the population. Then this is the key elements we always consider when we develop a solution in César, moving to TRL 678. At the end, the finality is to be deployable and bring benefits. This is one. Secondly, we have now those projects, some of the projects that we target TRL 8. And the aim of those projects is not only to create a prototype, prove that the concept is good, afterwards we dismantle those projects, like in Belgium or in Spain, Italy, or even Ireland and France. At the end, the aim is to set up the infrastructure, be TRL 8, perform operation, execute them. And I have even one project who claim that they will retrofit and reduce the project cost by the benefits that they may generate at the end of the project, thanks to the implementation of the infrastructure. You see, the target to business, target to operation, to target to deploy the system is always in our mind. Even though we have a complete research framework from fundamental research, application-oriented research with TRL 1 or 2, till TRL 8, then the path to go to operation, to business, with the mindset to industrialization is always there.
Fantastic. Andrew, do you have anything to, from a Eurocontrol point of view? I mean, Eurocontrol is an ANSP, it's a research agency, it does a lot of, it's a network manager. How it has so many different roles in here and so many different views from this. When we look at industry, I mean, we include ANSP as industry, do we here? This is how we define.
I think that's a reasonable approach. And I mean, you're based in Britain, Phil. You should be aware there are 69 ANSPs in Britain currently.
Yes.
So it is not intrinsically a monopoly business. The direction in Europe over the past 20 years has been to separate service provision from regulation, with an emphasis driven by the EU on lowering costs. So yes, it's a business. It's a regulated business, like a phone company or something else which is potentially monopolistic, but it's a regulated industry as far as the European governments are concerned. And Eurocontrol is subject to the same pressures in its ANSP activity. Network manager as well. The network manager has been appointed for a limited period. There's a review process. It could well be that another service provider could win that business. Thomas, don't get any ideas. But it is a service provided for a fee, and more and more we understand that always it's a business in effect.
Sure. Great.
Phil, just a quick one. I think the question and answers have opened up in case people want to post their questions.
Can I make one comment? I think if the new entrants have showed us anything, is our traditional way of looking at the cost and the benefit is kind of always been skewed towards the operations of large aircraft. And the economic benefit of these new entrants to the economy as a whole is something that we're not very good about looking at. And I think that that's one of the things we really have to say is, okay, they're not taking airspace away from the people who make benefit. They could be providing even more benefit. So we're going to have to figure this out, because you ask, well, what are the benefits? Well, I'm not sure we actually scratched the benefits for the new entrants at this point.
Right. Okay. So please send some questions in. I'm aware that we've skimmed the surface. There's masses more to talk about here. We've had one question in. FAA has a key site. Have there been any use-based deployments or certifications? Are we comparing like with like? The key site, which is still, I mean, it is operational drones, I know, but it's still in a trial test phase. So I'd expect it to be more comparable with some of the work that César does, perhaps. I don't know, perhaps I'm wrong there, but
well, I think the difference is we don't expect it. We're not going to tear it down. It's an operational eval that, as long as it proves valuable, it's going to stay there. And so this was not a demonstration. This is industry doing their first step. Now, it doesn't cover everything because they're not flying in all types of airspace yet, but it's not a trial. It's more than that.
And it's interesting the role that the FAA takes here as a kind of overseer rather than a direct regulator, is it not? I mean, that's one of the things that's quite interesting. The whole role of the regulator in an integrated UTM ATM system will be different from the.
We actually are the regulator.
Right.
The regulator, we gave them waivers.
Right.
So they're not flying without approval. Let me put it that way.
Well, no, but I mean, it's more of an authorization rather than a prescriptive rulemaking role that you have there.
Which is part and parcel of what we've been doing with new entrants for the last 5 or 6 years, but that's okay.
Yeah, good. Sorry, right.
Could I try and jump in? I've got something to say about that. So in Europe, there have been these 3 digital sky demonstrators. As Cengiz mentioned, they are leading to implementation. And today, Italy has sent a NOTAM for its first U-Space airspace. So it's called R700. It was announced today in the Italian AIP. So we are getting there. We are in the process in Europe of declaring U-Space airspaces, U-Space service providers, common information service providers. So we're not quite at the level of the key site in terms of have we got there. But on the other hand, ours is after the regulation has been published, whereas the key site in effect has been a preamble to the regulation. It's been built using waivers and exceptions, which presumably will be reflected in eventually the regulation, but ours has come in the other order. So regulation first, which is more in the need of Europe having 27 states. An EU regulation was a useful tool to avoid 27 completely different approaches to solving the problem.
That's really big news, Andrew. That really is. That's you heard it here first. Gosh, first U-Space.
Well, announced in the AIP. So it's called R700. If you look in the Italian AIP, you'll find it.
Thank you very much indeed. Okay, we have a question talking about separation in the UTM ATM integration. Who will be the separator as the new entrants transit in and out of controlled airspace? Perhaps, well, who wants to take that one? Perhaps Cengiz. I haven't heard from you for a while. Who is going to be the separator?
Separation management is one of the most complex topics we have in our CESAR projects. We have a specific project just for that. ANRA is part of this project. And this is the one we have the most biggest difficulties. Then we have scenarios of dozens and hundreds of drones flying together and how to separate them. And eventually we reduce the problem to let's try to make 2 drone flights at the same time. And this is the problem that we call the 2 drone problem that we ask majority of our projects to tackle. And for the moment, no answer. Yes, for the drones, it will be ground-based, but strategic, what happens tactically? When it's tactical, will it be still ground-based or with the drones themselves? We have not the answer. Maybe Andrew has some more elements because he's deep diving this project.
To answer that question, as it's written there, if it's controlled airspace, then it's a controlling service which must be used because that's the definition of controlled airspace. So we will expect an air traffic control service in the ICAO sense of the word. Today, that is the air traffic controller on his radio. Where we go in future, I mean, as I said earlier, I would expect that to be an air traffic controller who is assisted by a piece of software. So it could be that exactly which one of them is sending turn left heading 30 degrees it could be the human, it could be the piece of software, but between them, they will provide a controlling service. And that is the nature of controlled airspace. If we want to go beyond that, we need to go back to ICAO and talk about some other thing. And that'll be, well, a long process.
This is a very naive question, and I apologize for it. And I'm going to ask Andrew this one. Do we have any idea yet about what kind of sensors we'll need to put on a drone or an eVTOL to make it usable by a controller,
Well,
manageable by a controller?
it needs to be visible to the controller in the way that aircraft are today. Today we use radar because that's an appropriate technology, and we have also ADS-B, so the aircraft are broadcasting where they are, and we pick that up. And these technologies work at the kind of altitudes and speeds at which the traffic we're trying to handle is working. The problems that we're facing with small UAS is because they're very close to the ground. Neither of these is going to work very well. The antennas which they're communicating with would need to be many more and closer together. So there's an open question. What is the surveillance technology for low altitude? Different proposals under work, but eventually the concept will be there. We need to see where these aircraft are if we're going to provide a service to stop them banging into each other. So, yeah.
Yeah.
Simple as
So
that.
we like to look at the analogy that if you look at surveillance in air traffic in the United States or in probably the whole world, the surveillance is either the pilot reporting by voice or radar or ADS-B or providing positions over, like in the ocean, over a datacom service. So could we have positions provided by a network and not necessarily use the broadcast? Because the other problem with broadcast is you fill up this, you saturate the frequencies and you just can't see anything. So we have to use surveillance in the broader term, which is provision of position for the purposes of decision making, and then it opens up a wide range of possibilities, I think. And I think that Mr. Frequentis could probably tell us whether he agrees or not.
Please, Mr. Frequentis, do you agree?
Agree.
Excellent. Right, moving on. This one's for Amit. What's the demand signal for commercial UTM services? Are ANSPs tendering, and what are they saying about ATM integration? Great. In 30 seconds, please.
So yes, there is a demand signal. There are quite a few tenders out there today in the process where ANSPs are looking to either become single CIS or start offering the initial USSP services, depending on many member states, and not just in Europe, in other parts of the world as well. And are there commercial paying services? Yes. ANSPs is one part of the market. Then there are other potential new use cases and enterprise side that have need for airspace management or UTM services as well.
Great, thank you. Anybody want to handle the question on social and environmental concerns being addressed proactively? Will it be more of a retroactive approach businesses? I'm not quite sure I understand that one.
I could comment. If you look at the use-based regulation, there's a lengthy section, especially if you look in the exceptional means of compliance. There's a huge section about how the social aspects are dealt with, including during the setup phase and then during operations, so a monitoring process. So I would say look there if you want your answer, and then follow how it's implemented in the different states. But it is something which has been high on the list of priorities in how USpace is implemented. That's all I know about.
Great. And one final really interesting one, operational tempo increases. How does the group envision that the harmonization of the airspace and negotiations between operators will be handled, assuming some standards or rules would be required to facilitate automated conflict resolution? I mean, will these be letters of agreement between the various stakeholders? Standards? I'm not sure.
I can give you the view, because this is actually happening in some of, like, including
Right.
Keysight, because you have different operators. So everyone, if it's commercial operation, everyone comes in at the same priority level. So it's first come, first served basis. And eventually, when there's enough scale, we'll have to use that fair and equitable use of airspace. But then the additional complexity that's being added right now. We have public safety operators, not just commercial operators, public safety operators that are operating in the same realm. And now we are at the quayside, now the addition of prioritization. So which flight gets priority over the other? And it's not just public safety, it may be a critical infrastructure infection, a disaster response. So those things, there are standards that allow for the data exchanges like Tom and I was saying, but the regulatory overlay dictates how it should be implemented in the member state.
That's great, Amit. Thank you very much indeed, everybody. Thanks, Steve. Thanks, Andrew. Thanks, Thomas. Thanks, Genghis. Thanks, Amit. We've moved it along a bit. I'm still with all these huddles, you're left with as many questions at the end as you started out at the beginning, but they're different. So the questions are different now. So I suppose we can say we've moved it along a bit. Thank you, everybody else, as well, for listening. And I do hope you found it useful and interesting. I think these are really important events, and I congratulate the organizers for the high quality of speakers and questions. So thank you again very much, everybody, and I wish you a good day.